Scientists just took 200,000 human brain cells, put it on a microchip, and they adapted and learned how to play the video game Doom. This is a huge rabbit hole that is more than just about human brain cells playing a video game independently of the human themselves. This is going to lead on to mass innovation, possibly a competitor against artificial intelligence, and many more nuances that we're going to see in the next few weeks to upcoming years. I'm going to try to simplify all this for you in under 5 minutes, so stay with me, lock in. This is crazy. At the time of making this video about living human brain cells playing Doom from Cortical Labs, which is the scientist behind this experiment, only has 69,000 views. It's 11 days old, and it's really just getting picked up the last few days of this whole thought experiment of these brain cells playing Doom. I expect this video that's at 69,000 views to be over 1 million views in the upcoming month. We'll see if that happens or not, and it's 11 days old, so the trajectory isn't on my side for that prediction. In 2022, and just to save you from watching this whole video, which is a short video, and I recommend going to watch it, but I'm going to talk about a lot more implications and a lot of sources and things outside of this video. In 2022, they grew the brain cells on a microchip to play the game Pong. Pong is just the game that hits the ball back and forth. And this took them, I want to say 18 months to be able to do. However, in 2026, it only took them 1 week to be able to do the video game Pong. And what they do essentially, they don't talk about in depth in this video, is they take your blood sample, they extract cells from it, and then they extract the neurons from the brain. They put the neurons from the brain onto this microchip like you see right here. And that's the founder right there, Dr. Alan Loeffler, who is talking about it. Again, if you want to watch this video, I'll leave it down below in the description. And they basically train these neurons to play the video game, which at this point is Doom, a lot more complicated than Pong. The way that they train them is quite an ethical concern to some. It is on this machine, which is their CL1 machine, which essentially ran and has all the brain cells on it. You can see the brain cells reacting to the simulation here. This is a real gameplay again on their Pong, where you have the different regions of the brain firing up electrical currents and being able to play the game. So when they actually explain the process here of what they do and how they get them to respond, it's actually quite interesting. So all of these brain cells and everything operates off of energy / electricity, like electric zaps to your brain cells. So they're claiming ethically that this is okay, even though it's like, the human brain cells, because what they do is they give it a feedback loop. When these brain cells figure out that they're doing well in the game, they keep the electrical currents consistent for the brain cells. However, when they do something that is not okay, they create chaos in the electrical current and make it inconsistent, which the cells do not like. The cells gravitate towards consistent energy. So this is how the cells are able to adapt and learn to play the game independently, because they're able to basically figure it out due to electrical currents and trying to maintain that consistency, again, without any sort of human interaction. I want to talk about the ethical concerns at the end of the video. I want to give you objectivity when actually explaining this and showing you how all this happens, as well as the next phase for this, because it gets even crazier than what you might think. So Akash Gupta put one of the most interesting takes that I've seen yet. He's saying that most of this playing Doom on this chip is definitely just kind of for marketing. The deeper and interesting concept here is the fact of the actual energy cost and the ability of this biological intelligence that comes from humans competing with artificial intelligence. And basically what he's saying is, like, again, can it run Doom? It's missing the unit cost, which is $35,000. A full 30 unit server rack draws 850 to 1000 watts total. Your brain runs on 20 watts. A single GPU cluster training an LLM can draw megawatts. The energy economics of biological compute are orders of magnitude better than silicon, which is AI, and gaps at scale. The investor list tells you who to pay attention to. So basically he's going into the investor on it. And Cortical Labs is now selling a wet-ware as a service through the Cortical Cloud. Developers can deploy code to living neurons remotely without touching a lab. they're pricing access at the level of software subscription while the hardware runs on real human brain cells derived from an adult skin and blood samples. So this is where it goes down a rabbit hole, because while it's not serving as the compute power, it's showing that it's adaptive and can be used to, be able to learn things. So with how much AI costs and all these resources and these data centers and everything else that's going on in artificial intelligence, why not just use something natural like human brain cells that would be able to do similar tasks as AI, except they're biological, they're not artificial. They don't have the parameters as artificial intelligence. They have actual living organisms that can use to be able to adapt and learn. This is just a very interesting study, and just be able to look at and just observe what all is going on here. Now, I want to keep this at 5 minutes or under, so I don't want to spend too much of your time on just my take here, but this is one of the most interesting things that I've seen in a long time, and that's coming from somebody who is very early to artificial intelligence. It breeds the ethicists' opinions on this, because while they say they're just adding electrical currents and taking away electrical currents, and these cells can't, feel, they don't have chemicals, they don't have dopamine, you're still kind of punishing the cells to live in, well, doom, and train them based off of electrical currents. If there is more to this that we don't know, then this could be definitely a huge ethical concern. In my opinion, this is also getting really close to duplicating what makes humans unique and us. And what we see now is it running on this CL1, this little long thing that you just stick the microchip in. But what happens when we get this thing a flesh suit? And what happens when its adaptive technology makes it functional, if it's able to get to those points, or when you could even give it chemicals to give it an array of emotions, and I'm sure at that point you'll say, oh well, what's real emotions, what's inherited, what's learned. But how far this goes in the next few years is going to be mind-boggling. And right now, Cortical Labs is at the ground level experimentation with what is basically, from my brain, I just like to understand BI. It's not the best thing, but biological intelligence versus artificial intelligence. Again, artificial intelligence has guardrails to where it can understand rules without even knowing why it needs to understand rules. Whereas biological intelligence can adapt and learn things without even knowing the rules, and maybe even the idea to break the rules. So this whole thing is just mind-blowing and insane. If you ended up watching this video, just let me know what you think about this down below. I genuinely want to know that. What do you think about this? Are we crossing boundaries that we shouldn't be crossing here? Is this good for science? All those things, and I'll see you guys next video.